right, Mark, greetings. And Matt, greetings. The internet, greetings. Let's do chapter 2, mathematical reasoning, logic, and set theory. In order to communicate mathematical ideas effectively, formal languages have been developed within which logic, i.e. deductive mathematical reasoning, can proceed. Propositions are statements that can be either true or false. Axiomatic systems begin with statements, axioms, assumed true. Theorems are proven by deduction. In many forms of logic, like propositional calculus, compound propositions are constructed via logical connectives, like and or, of atomic propositions. And we're going to get into that in section 2.2, lecture 2.2. In others, like first-order logic, there are also logical quantifiers, like for every, and there exists, okay? The mathematical objects and operations about which most propositions are made are expressed in terms of set theory, which was introduced in section 1.2 a little bit and will be expanded upon in section 2.1. We can say that mathematical reasoning is comprised of mathematical objects and operations expressed in set theory, and logic allows us to reason therewith. So that's kind of like mathematical reasoning, logic, set theory. I wish that they taught this stuff to your average engineering undergraduate student, but they don't. So I thought we would do a little bit of review. Kelsey, I think you're going to be ahead of the game on some of this. Yeah. Spend a little bit of time doing this stuff. Yeah. Okay. So that's the sort of the project of chapter 2, which we're going to cover completely today. We're just going to get a little bit of an introduction to each of these, to set theory and to logic. Okay?
2.0 lecture link broken in your website. You got the 2.0 link?
Oh.
No.